Our next subject is capital asset pricing model. It is developed by Dr. Harry Markowitz from University of Chicago, and this model helped him win the Nobel Economic Prize in 1990. And you can see that this model is a big hit in the modern finance theoretical world. So in this model's framework, we assume that the risk level of an individual stock varies with the risk level of the market, and also the risk premium of this stock is at multiples of the risk premium of the market. Okay, so in this model, CAPM, you will see RI as the return of individual stock. RF is the risk-free rate, okay, offered by the U.S. government. It's a T-bill rate, and we have the multiplier. BI is actually should be called a beta. Okay, I want you guys to know this name, beta. A beta is a multiplier, and also right here you have the market return minus risk-free return. Okay, so the individual stock return minus the risk-free return would give you the stock risk premium. If you use a market return minus risk-free return, you will get a market risk premium or excess market return. So any return minus the risk-free rate would be the risk premium. Okay, so we need to exclude the risk-free part from the market return, from the individual stock return, because everybody is getting risk-free rate. So if we exclude the risk-free part, then the rest of the return would really be based on the risk level. Okay, and if you twist this equation a little bit, you move the risk-free rate here to the right-hand side of the equation, then your individual stock return is the only one standing on the left. So it equals to the risk-free rate plus beta times the market risk premium, which is in this parenthesis. Okay. So the market return is easily to get. So when you drive your car, you can hear from the radio that the Dow Jones up and down by certain points, NASDAQ, Standard & Poor's, and these are all good indicators of the market returns. Okay, and right here I have a screenshot from a CNN Money on one day in 2015. And that day, the stock market basically increased by roughly 2.2%, depending on your indicator. Okay, so that's a pretty huge increase. If every day it increased by 2%, then in the 250 trading days of the year, it will be a 500% increase. But that's not quite possible. So let me just briefly introduce you this beta. Actually, your entire Excel project, I think it's a project of 5 or 4 is based on estimating beta. So beta is a correlation between individual stock risk premium and a market risk premium. Again, risk premium is the return excluding risk-free rate. Okay, and the beta basically measures the a stock's market risk. So the portion of a stock risk that is in relationship with the market risk. Okay, so that we call it stock's market risk. And this beta shows you stock volatility relative to the market volatility. And it is a multiplier. If beta equals to 2, basically that means if the market risk premium increased by 1, then the stock risk premium would increase by 2%. Okay? So if beta is a negative, then the security or the stock would move to the opposite direction of the market. So when the market is going up, the stock would go down. So if absolute value of beta equals to 1, then the stock just as risky as the average stock in the market. Okay, if a beta is greater than 1, then the security is riskier than average or the market. Okay, if a beta is less than 1, the security is less risky than the average. Okay, or the market. The most stocks have a beta in the range of 0.5 and 1.5. In the Excel project, right here. I think it's Excel Project 5, you are asked to estimate the data for a stock called a General Electric. Okay, so you have the data from the market. Okay, you have the data from the market, and you have the data from the stock. Okay, and then you have the data for the U.S. Treasury bill, which is your risk-free rate. Okay, and then you use the data to estimate the beta. Okay, unfortunately, that beta for GE falls out of this range. It's actually negative 0.4 or something, okay, which means when the market increased by 1%, GE stock actually decreased by 0.4%. Okay, and you also have the beta by industry. So the industries with higher beta would be real estate industry, energy industry, food industry, and so on. Okay, the industries with a low beta are usually the highly regulated industries like the banking industry, the utilities industry, the financial industry, on and on. All right, so the implication here is if the market is going up, so you would hold the stock with a larger beta because when market increased by 1%, then this stocks would increase by more than 1%. So for large beta stocks, that's when you want to hold when the market is going up. So if the market is going down, basically you want to hold the stocks with a negative beta. Okay, so when the market is going down, then this negative beta would go up, just like the GE stock I talked about. So when the market is going down, like right now, the GE stock probably will bounce back. Okay, if you're not sure about the market, you don't know whether the market is going up or going down, then you probably hold the stock with a very small amount of beta. Okay, so that means if the market increased by 1 or decreased by 1, then the stock return just doesn't change as much as 1%. Okay, so if you're not sure where the market is going, you just hold small beta stock. In terms of calculation for CAPM, this is kind of question I would like to give you. So if a stock has a beta 1.3, the risk-free rate is 6.5%, and the market return is 13%. So based on the security market line or CAPM, what is the firm's required return? So you move back to the formula. It's right up here. So based on the CAPM, the stock return equals to risk-free rate plus the beta times market return minus the risk-free rate. Okay, if you just follow the math work, then you should easily get the answer should be E. Okay, I do not go through the calculation here. I think it's pretty easy. Just to make sure you verify that answer when you have some free time. All right, the next one, a stock has a beta 1.4 and the risk-free rate is 4.25% and market risk premium is 5.5. What is firm's required rate of return? It looks a little bit the same as the last one. However, there's a big difference. What is provided to you by the market is a market risk premium, whereas in this question you were given market return. Okay, the return on the stock market is 13%. The market risk premium is given here. So the difference is the market risk premium is market return minus risk-free rate. Okay, once again, market risk premium is a market return minus risk premium. And in the formula, so this part, this Rm minus Rf is a market risk premium. Okay, so you don't need a market return once you have market risk premium already. Okay, you just use the market risk premium multiplied by the beta, then you add risk-free rate to get the stock return. Okay, so the answer for this one should be C. Just make sure you verify that answer. For the next subject, we talk about the standard deviation. Standard deviation is the measure for risk in the world of finance. Okay, and you have probably learned this in your statistics class. Larger standard deviation means a lower probability that the actual returns is close to the expected return. So that means the value that came out would be more spread out around the expected. Okay, so first of all, you should know what is the expected return. Right here, you have a summation, okay, of different returns, and each return comes with certain probability, some with a 10% likelihood to come, and some with 20%. So those are the P's. So each probability times each return, you get a product, and then you sum them up to get the expected return. And how do you get the standard deviation? You're going to use each return subtracted by the expected return. You take the square, you get a squared deviation, okay? And then you multiply it by the probability, then you sum them up. That's called a variance. You take the square root of variance, you get a standard deviation. Since this has already been covered in your statistics class, so I'm not gonna go over too much for the details. And here is a combination of a risk and return, and this is something I really want you to remember. This is called a coefficient variation, where you have a standard deviation on the top, expect return down the bottom. So you want this variable to be as low as possible, because you want to minimize the standard deviation, minimize your risk as low as possible. On the other hand side, you want to increase your expect return. You want to maximize your return down the bottom. Okay, so you want a low denominator and a high. You want a low numerator and a high denominator. So that's a small coefficient variation. That's a desirable one. All right, and for this problem in your textbook, you have 5 different probabilities and 5 different scenarios. Okay, so for the weak economy, you have a 10% probability. For the below average, 20%. For average, 40%, so on and so forth. And when you add all the probability together, you're going to get 100% or just 1. All right, and under each scenario, you would come up with a certain return. Okay, so you have 5 returns for 5 scenarios. So that's for the stock. And for the T-bills, it always stay at 5.5%. Okay, always stay at 5.5%. And if you put in the formula, as I showed you earlier, this is a formula for expect return, formula for standard deviation. That's the process you need to go through. Okay, so you need to use each probability times its return plus each other probability times its return, and you're gonna add all these products together to get expected, and then you need each return subtracted by the expected, which is 11.4%. Take the square, multiply by the probability, and then add them up. Okay, and then you take the square root of the whole summation, you get a standard deviation. Okay, that's a very long and tedious process. In your on the canvas, in your module, risk and return, if I scroll down, and you will see that I have posted a link here, which teaches you how to use your calculator to do the job. Okay, and right here is your is oops. Right here is the calculator, and these are the buttons you see, just like your own TI 83 or 84. And so basically I teach you how to click the buttons and what function you should use. Basically you should hit this stat button of your calculator and edit the columns with your numbers, and then perform the one variable statistic calculation. All right, so make sure you go through this video on the module to get familiar with the process, how to get the standard deviation for this kind of problem set. The good news for you is you don't have to go through this whole thing, this whole mathematical process. As I said, it's long and tedious. You just need to go over the module, okay? Watch the link about using the calculator, then you should be fine. So you don't have to go all of this, which has a lot of room for errors. Okay, so this is for the stock or the company's product. Okay, and you also have a T-bills. So if you use a T-bills and you use the formula, then the standard deviation is 0%. As you can see that the T-bills always stay at 5.5%. There's no variation. There's no deviation from the expected. It's always 5.5%. So that's why you see the risk is 0% for the T-bills. Okay, so if you measure the risk based on scenarios, which is what I just did. That's the process you need to go through. Okay, if you want to measure the risk based on historical returns, then your formulas would change. Okay, so the expected is just the average of returns, and the formulas is changed to this. You do not have a probability variable, because each return comes with the same probability. You just need to treat them equally, and after you add them up, you divide the whole thing either by 1 over n or 1 over n minus 1. So when do you use 1 over n? When you have all the returns in the history. So basically all the returns you play with is the entire population. Then you use 1 over n as a multiplier. if the returns you play with is just a sample of the population, let's say this company has existed for 200 years and you only play with 4 years of data, then you just play with a sample of a population. Then you should use this multiplier, 1 over n minus 1. And for most of the cases in my class, we are going to use this multiplier, 1 over n minus 1. Again, in this module of statistical problems, I teach you how to distinguish the case whether you use 1 over n or 1 over n minus 1. Okay, so I'm gonna give you this practice. Okay, so just to make sure you go over all of them once you get a chance. And if I put all the work here in Excel, so just to make a comparison, in Excel it's going to be pretty easy, and you also have a Excel project 4 to do the job. For the time being, let me just briefly teach you how to get the expected return for the scenario-based set and also for the historical return-based set. I just call it time-based. So for the time-based, it's the easiest thing in the world. If you want to get the expected, so you just put an average. Oops, that was the Chinese input system. I'm sorry. So average, and then you get circle all the returns, and then you hit enter. Okay, and that's it. So that's the return for all three. That's expected for all three returns. And for the expected return based on scenarios is a little bit harder. So you need to incorporate the probabilities and also the returns. So you need to use each probability times each return. Okay, you have 3 products and then you add them up. Or in Excel, we make things easier by using sum of product function. You circle all the probabilities and then you circle all the returns. Make sure you connect them with this multiplication sign. And if you want to finish, you hit Control-Shift-Enter. Do not just hit Enter, hit Control-Shift-Enter because this calculation involves vector of numbers. Okay, so that is your answer for expected. Okay, and to get a standard deviation, the time-based case is much easier. So standard deviation here, you just use you have 2 numbers, so that's the standard deviation based on the entire population. So you can see that the p is something extra I put in there. So let me just put a p here. P stands for population, or you can just use a STDEV. That's it. And STDEV basically recognizes all the 3 returns as a sample of returns for the entire history of the stock. Okay, so use STDEV, and that's your answer. And to get the standard deviation of a scenario-based, that's pretty tough to do. Okay, because you need to use each return minus the expected. Okay, you need to log. And to get a deviation, all right, to get a deviation, and then you get 3 deviations, and then that's not enough. You need to take the square of each deviation, okay, to get a squared deviation. Okay, so that's a pretty tedious process. And after you get this squared deviation, you're gonna sum them up. Okay, and when you sum them up, you also need to incorporate the probability is actually the weighted summation of all the squared deviation. So I'm going to use this probability vector multiplied by the vector of squared deviation. All right, and then Control-Shift-Enter. Okay, and you are still not done yet. It is called a variance. To get the standard deviation is actually the square root of this variance. Okay, so this is 7.3% is your standard deviation. All right, so as I mentioned earlier, the best way to do this kind of work is to use your financial calculator, so you don't have to go through each of this process, or you don't have to go through a mathematical process like this. Okay, that's just too much. So you need to rely on your calculator to do that kind of job. On the other hand side, if you have historical returns where you do not have any scenario or probabilities with the scenario, you should use this Excel to do the job. It's much easier. All right, so get back to where I left out. Right here, you have 4 returns, and you can solve for the standard deviation as well as the expected return. On the tutorial of the calculator, I have showed you how to do the work. So this part, it would be finished if you finish watching that tutorial video for a calculator. Okay, our next subject is about portfolio management. Well, portfolio is a collection of different securities such as stocks and bonds. So it's a combination. And when you diversify your investment, you should be better off. And I will introduce you what's the benefits for diversification. Okay, so first of all, the diversification would avoid all the eggs get broken if you put them in one basket. Okay, and also if one and the overall risk, okay, we're talking about the standard deviation of the entire portfolio would be reduced if you keep adding more and more securities with a negative relationship that has negative relationship with the existing portfolio. Okay, well, that sounds a lot to understand. For a short moment, I will show you exactly how this goes in examples. Okay, first of all, you should know how to get expected return for the portfolio. Again, you have this concept of a weight. So this weight is a percentage of the investment you put in certain stock. Okay, so you use that weight multiplied by the expected return of that stock. Then you have one product. Then you get the summation of all the products to get the expected return of the portfolio. Okay, for example, when you have 2 stocks, stock A and a stock B, and your total investment is $7,000 with a $2,000 in A, $5,000 in B, stock A give you 14% return, stock B give you a 6% return. The first thing you should do is to get a percentage weight. Okay, first and foremost, you do not use dollar signs for these W's, okay, for these weights. You should use a percentage. Okay, how do you get a percentage? You get a total, and then you use each individual investment by the total. Okay, so make sure you verify these numbers. Okay, after you get the weights, you use each weight multiplied by each return. So weight A, which is 28.6%, multiplied by 14%, and do the same thing with B. Okay, and then you add it up to get the expected return for the portfolio. When you have 4 stocks like this, so each of them you invest equally with $25,000. Okay, how do you get the weights? You need to add them up to get the total, which is $100,000, and then use each of the investment divided by the total to get a 25% as the percentage weight. Okay, the expected return of the individual stock is given, so you use the expected return of a stock multiplied by the weight, you get a product, and after you get all 4 products, you add them up to get the expected return for the portfolio. Okay. All right. So the range of a return in the 2 assets would be just cut in the middle. Let's say if you have a stock A with a return of 8% and a B has a return of 10%, then if you form a portfolio, no matter how you play with the weights, you could have put 10% in A, 90% in B, or 50-50, or 0, 100%. Okay, then the portfolio return does not escape the range from 8 to 10%. So here is a simulation I did. So A gives you 10, B gives you 8. Then this would be the possible weight combinations. So each row, it will represent a possibility. So 0A, 100 in B, then the portfolio return would just be 8%. If you put 100 in A, 0 in B, the portfolio return would be just A's return. So anywhere in the middle, you'll be cut between 8 and 10. So this is the chart that shows you how the expected return of the portfolio would change according to the portfolio weights you put in A. Okay. All right. Here is an example, which is very similar to your assignment number 3. Okay. This is assignment number 3. Sorry, this is assignment 2, question number 3. What you need to do is first to copy these numbers in your Excel, and then you need to calculate the expected return for A and B, and then the standard deviation for A and B, and then coefficient for A and B. Since this is an assignment, it's not Excel project, I'm not gonna show you step by step how to do this. Rather, I'll give you a similar example like this. Okay, so how do you get the expected return for A and B? That's fairly easy to do. You just take the average, okay, of A historical return and then B's historical return. Okay, increase a little bit decimals, and then the weights I put here is 50% in A and 50% in B. Okay, so the portfolio return is just 50 of this and plus 50 of that. Okay, so I'm going to use 50 and make sure I lock it. Okay, so far you should know what locking means. Okay, times 15 plus this weight, lock it. Okay, hit F4, hotkey F4 for lock, times it's a B's return. Okay, hit enter. So that's portfolio return for January, and then drag it all the way down. Oops, that's 10%, and this I can drag it down as well. So as you can see, the portfolio return will be just in the middle between the two returns. Okay. All right. So now let me do this. I'm going to make B's return as 1 minus A's return. Okay. So if I change A's return to 40%, you will see that the portfolio return is getting lower towards A's return. If I change it to 0%, then the portfolio return will be just exactly B's return. If I change A's return to 100, so you will get to A's return. Okay? So the bottom line is, all I want to say here is the portfolio return just cut in the middle between A and B. Okay, it cannot go below A or go above B. All right. So the next thing I want to say is about the correlation. All right. So here I got a stock W and a stock M, and they both give you an average 15% return across the 5 years. Okay, for W is 15, for M is 15, and the standard deviation for them is also the same, which at 25%. Okay, so if you form a portfolio with half in W and half in M, then the expected return is 15%. Okay, you see 15% for all the years, and then 15% for the expected. Okay, but what about the standard deviation or the risk for the portfolio? Okay, you can see that the portfolio return always stay at 15%, right? There's no variation. But with the individual stock, they both come with a certain level of risk. Does the portfolio risk cut in the middle? No. The portfolio risk is not cut in the middle between 25 and 25. Rather, the portfolio risk is 0. Okay, the portfolio risk is 0. As you can see, there's no variation here. So if I plug them into a chart, so here is a W and here is an M, and if you form a portfolio, it's just be the flat, solid green curve, okay, which ensures a 15% return where there's no fluctuation at all. So the risk of the portfolio is 0. That is called a hedging, okay? Actually, the entire hedge fund industry is based on this ideology. You find two assets that has a negative correlation, okay, and their risk would cancel each other, so you would reach a good hedge position, so your risk is minimized, and you reach the best portfolio. Okay, so here it comes to an idea or this concept of a correlation coefficient. So correlation coefficient measures the degree to which two variable moves are associated. Okay, so you may have a -1 to a +1 range for correlation coefficient. If it is -1, it means negatively correlated. that basically means if A increase by 1, B will decrease by 1. Okay, exactly same magnitude, but exactly opposite direction. And a positive 1 correlation means the perfect positive correlation. So if A increased by 1%, B would increase by 1% as well. So it's the same direction, same magnitude. Okay, if we look at this case, A and B, the correlation between these two, in Excel, the formula is a correl, okay, is negative. Well, you need to find negative correlations, okay, because that's going to help you reduce the overall portfolio risk, okay. So right here, if even the correlation is not that perfectly negative, or even the correlation is not negative, still your portfolio is better off by adding this new stock. Let's say you have a stock W and you have stock Y, okay? These two stocks both have a 15% return and a 25% standard deviation. Their risk level is the same. But when you combine both of them, although W and Y has a correlation of a positive 3.5, which is not that high, your portfolio risk is lower than any of these two. Okay, so that's the beauty of diversification. If you add stocks with a low correlation, okay, then your portfolio risk would be reduced. Okay, and the whole idea for diversification is if you have a lower or even negative correlation between constituent assets, then you would reach better diversification. So better diversification is defined as a more risk reduction with little effect on returns. Okay, and based on this, you can decide what ways you put on the constituent securities. Actually, your project, your Excel project number 4 is about a portfolio management of two stocks. One is Microsoft and another is Amazon. And then I teaches you in this project how to allocate your investment between Amazon and Microsoft. Okay, so just to follow the instruction of the video I posted, you should be fine. All right. All right, and also your second report. Let's say you have a let me click on the assignment here. Your second assignment, second report is about diversification. All right, so you are going to watch a YouTube video that's by David Swanson from Yale University. He's managing billions of dollars for the university, and he just teaches you what makes him successful. Okay, he basically says diversification is a king to managing your money. All right, and based on this video, you don't have to watch the entire video. You just watch the first 33 minutes of it. You're gonna write a report. Okay, write a summary for the video. All right, so the last graph basically shows you this. If you just pick a stock, okay, just pick a stock in the U.S. market, on average, this stock would give you 35% standard deviation. So that's how much, how risky an average American stock would be, 35% standard deviation. And if you pick another one, okay, if you pick another one, the second best one, then the portfolio becomes to a two-stock portfolio, then the overall risk would be reduced from 35% standard deviation to 30%. And if you keep adding more and more, your portfolio risk will be reduced from 35 to 30 to 25, on and on, okay? And then eventually it will reach to the market risk, which is at 20.4%, okay? So just when you add more and more portfolio, you add 1, 2, 3 to 10 to 20 to 30 to 40, and then your portfolio risk would approach to the market risk. Okay, and there are certain points you should stop, because when you add more stock, you need to pay transaction fee to the broker. Okay, so there's a cost when you add more stocks, and there's also benefit when you add stock, which is risk reduction. The thing is, you should stop somewhere between 30 stocks to 40 stocks. Okay, people say it's 36 or 37. right here. Okay, that's when your marginal benefit equals to the marginal cost. So if you keep adding more stock, then the cost to add that additional stock would exceed the benefit for adding the stock. Okay, so that's where you stop. So the benefit for adding the stock would be risk reduction. All right, so for this one, if you wanna get the standard deviation for stock A, okay, it is STDEV. You just go ahead and do it. All right, so you get a 12.7% standard deviation. You just drag it all the way. You're gonna do this in your homework. In your assignment 2, you're gonna do this in your Excel project 4. Okay, as you can see that for the portfolio, this is what I want you to look at. The return is not compromised; it's cut in the middle, but the risk of the portfolio is lower than any of these two stocks. You see it's 12.7, 8.1. When you combine these two, the stock price, the stock risk, the portfolio risk is actually lower than both of them. Okay, so that's the benefit of diversification.